One is 16.3. It's about sector areas, and I think you'll find it's actually it'll be pretty short and pretty sweet. And if you can do the arc length stuff, you can do the sectors pretty easily here. Um, so just a quick definition of sector. So a sector is formed by a central angle, and it's the area of that portion of the circle, right? So in this case, we could call this sector POQ, um, or the sector defined by angle POQ, something like that. Okay, and it should be no surprise here. You should probably already be able to figure out the formula for a sector, right? Based on this angle, right? We can figure out the portion of the whole. So the angle is going to be m over 360, right? That's the portion of the whole. What is the area of the whole? Well, it's pi times r squared. So this will be our formula. The sector area, oh wait, yeah, sorry. Why did I put the arc length one in here? Just a reminder, arc length is equal to s, or is equal to m over 360 times 2 pi r. Therefore, the area of a sector is the measure of the arc, or the measure of the, oh yeah, you could either use the measure of the arc or the measure of the central angle divided by 360 times pi r squared. That's our formula there. We'll do a couple examples, and that's pretty much it. We have sector POQ, so P to O to Q. Note here, though, that this isn't the cleanest because if it wasn't shaded, you would think that it would be this sector here on the left. So P to O to Q is going to refer to this shaded area. We'll try and make it very clear on all the problems you have coming up. So POQ is 210 degrees. So we plug in 210, turn the crank, we get 21 over 4 pi. Again, I am more than happy to accept that answer. You don't have to have a calculator to punch in to find a bunch of decimals for me to decide, oh, you did it right. If you get 21 over 4 times pi, or 21 over 4 pi, cool. That's the most accurate answer you can put. So, good job. The second one here, sector HGJ. H to G to J. Again, we're going to use shading to clarify that it's this one on the right. It's 131 degrees. The radius is 12. So we can plug that in. 131 divided by 360 times pi times the radius, so 12 squared. Just a note here, anytime we have a formula like this, it may seem super obvious, like, oh yeah, you just plug it in and do the math and it's not a problem. But let's pause this video at some point here. Actually put this into your calculator. See if you can get the same answer they get. See if you can do it with getting pi, just solving for, leaving pi as kind of like a variable without multiplying it. So see if you can do that now. But it's important that you actually check to see if you can do these steps on a calculator, especially since people have different calculators, etc. So when you simplify it down, you get 131 over 360 times 144. 131 over 360 times 144 gives you about 52.4. Again, you don't have to go crazy here because this doesn't divide very evenly. So this 52.4 is an estimation, but then that leaves us pi outside again. So it's relatively accurate. Okay, see if you can do 4, see if you can do 5. I'll pause it here. Pause. Okay, number 4, AOB is simply 1/2 of the area, which is 0.64 pi. So 0.32 pi is perfectly accurate. For this other guy, POQ is 22.5 divided by 360 times pi times 24 squared, which gives us, sorry, I can't see that, about 36 pi or 113.10. Again, I prefer this, but I'll totally accept these decimal answers as well. That's fine. Okay, they're going to start making these harder because this is a little too simple, so they're going to be like, oh, let's put in some word problems. So for word problems, don't think of these as like super formulaic, right? You just want to try and kind of identify what's going on, draw a picture if you can, see if you can figure out which formulas you may need, what information you have, what type of information that is. So the first says, a beam from a lighthouse is visible for a distance of 3 miles. To the nearest square mile, what is the area covered by the beam as it sweeps in an arc of 150 degrees? So we'll draw our little lighthouse. Here's our lighthouse. I'm going to make it cool looking. It's like it's on a jagged rock too. Here's the rock. Cool. Use yellow, I guess. So it has a beam of, as it's sweeping in an arc, it's going to start down here. It's going to sweep up 150 degrees, so close to 180. And the distance that it can go, because it's all foggy and stuff or whatever, is 3 miles. Is that radius? And we want to know what, there we go. We want to know what the area of that sector is. So in this case, the radius is 3. Put equals r. The number of degrees is 150. Therefore, I can again plug my values into that formula. 150 divided by 360 gives me the portion of the whole. And the whole is 3 squared times pi, or 9 pi. So, sure. Which gives me, what is that? Divided by 3, 5/4, 15 fourths pi, or approximately 12. What information do you need to find the area of a sector? We just got this one on the lighthouse problem, right? What were the two things? We need the radius, and we need the number of degrees. I don't remember writing size here. My only point here was that we need to figure out how big that triangle is, right? You may not be given the radius, right? It may have a circle here and it says, oh, the central angle is, I don't know, what is this, 100 degrees, right? So it says, okay, this is 100 degrees. But you should be able to solve no matter what information you're given that leads you to figure out the size of that circle, right? If you're given the diameter, you should be able to divide that in half, square it, and then multiply that by pi to find the area. If you're given the area, then that's fine. You basically have, this portion of the sector area formula done already. So you can just multiply that by the fraction of the whole. A great test question, hint, hint, wink, wink, maybe to do a sector area where I give you the angle here in radians, right? So just keep in mind, we need to figure out what that angle is. We need to figure out the size of the circle. That's all we really need, even though the formula calls specifically for the radius. Okay, that's all. Thanks. Have a good one.